Mechanical engineering is a branch of engineering that focuses on the design, analysis, and manufacturing of mechanical systems. This major is highly math, especially calculus, and physics based. One of the great things about mechanical engineering is that it is highly versatile in what you can do. Students who graduate as a mechanical engineering major can go into construction, automotive, heating and air conditioning, materials, robotics, work in the energy sector, combustion engines, and many more. Now, besides mechanical engineering classes, you'll take a little bit of everything basically. You have to take a few electrical engineering classes to learn about the basics of circuits and possibly some of the basics of electronics as well. You have to do a little programming and become decently proficient in MATLAB, which is a software that allows you to create plots and graphs and do complicated math way beyond what your graphing calculator can do. You'll possibly have to do a welding class, then of course you have to take about 2 years of math, mostly calculus, and about 1 year of physics. Now, the first main class of mechanical engineering would be statics, where you'll look at the physics of systems that aren't moving. This would be like looking at the forces and torques in something like a truss that holds up a bridge, where you have to analyze the forces that individual beams feel due to external forces. Then the next class would be dynamics, where you look at systems that are moving. It's similar to your high school physics class with projectile motion, momentum, energy, forces, and more, but is much more involved. You'll look at the motion of much more complex systems, have to find things like velocity, acceleration, energy, force, and more of different parts of that system. Then your third year, you'd even take a more advanced version of this class, where you look at these complex systems, but now in 3 dimensions. So as you can probably already see, mechanical engineering involves a lot of advanced physics. When you enter your third year, you'll take a course called Fluid Mechanics, and in this course you'll study the properties and mechanics of fluids such as air and water. This class is very calculus based. For example, you could study how the pressure of water changes as it flows through a set of pipes in a closed environment as height and pipe dimensions change. The principles to solve this are foundational for how your car brakes work. This class also includes the physics of how wind turbines work and why they are made the way they are so that they move as much as possible from any amount of wind. And you can analyze why different shapes are better or worse. And if airplanes interest you, you can even learn how wind flows over a wing to produce aerodynamic force, which also applies to car aerodynamics, which if optimized increases cars' MPG. You also take a class called Thermodynamics, which deals with the relations between heat and other forms of energy, such as mechanical, electrical, or chemical. In this class, you'll study the combustion engine, which applies to cars, boats, and aircrafts, and you'll learn these engines in great depth and see how they are constantly making adjustments to make them more efficient. You'll go as far back and learn at how the first steam engine was created, and you'll learn how similar ideas are still being used in power plants today to produce energy to power your TV, turn on your lights, and power your appliances. You'll then take a vibrations class where you'll analyze the mechanical vibrations that occur in different objects. Think about if you were to drop a metal object. When it hits the ground, you might observe or even hear it vibrating. Well, in mechanical systems like planes, cars, satellites, and more that are moving but also contain parts like motors and engines that are also moving at very high speeds, it's important to analyze the system even down to the vibrations to ensure the system can withstand those vibrations that occur. Have you ever seen in movies a person make a high-pitched note and it causes something like a glass to shatter? That's because the sound is making the glass vibrate at just the right frequency, called the natural frequency, that makes it shatter. Buildings even need to account for this, because in the case of an earthquake, the building will shake and vibrations will be created. This is actually a building in Japan that was structurally built to withstand high winds and strong earthquakes from causing strong vibrations. One thing they did was put something called a tuned mass damper near the top of the building, which weighs 728 tons. And is something that is engineered to reduce mechanical vibrations that can actually save the building from destruction during natural disasters. In 1940, the Tacoma Bridge collapsed, and what they found afterwards was the vibrations occurred due to interactions between the bridge and the wind, which just kept amplifying until it fell apart. Like most mechanical engineering classes, this one is highly calculus based because you have to model very complex systems and motion. Then you'll take some design classes, and these are kind of a combination of materials engineering and mechanical engineering, where you'll look at the strength and durability of different materials, mechanisms, and structures. As a mechanical engineer, someone might tell you they need a certain motor to make 1,000,000 cycles without braking, or maybe they need it to run for 10 years without braking. This could even apply to just how much weight can a beam support before braking and how much stress is it subject to with a certain amount of weight. Now there are a few concentrations within mechanical engineering. A few specific ones include heating and ventilation, air conditioning and refrigeration, or HVAC as it's called, then mechatronics and manufacturing. Now HVAC goes into more vehicle and indoor comfort using your knowledge of fluids, thermodynamics, and heat transfer. An HVAC concentration leads to working on maintaining heat and ventilated air in something like a large commercial building, cars, apartment buildings, homes, hospitals, hotels, and more, where you'll have to understand how heat travels throughout the building and different materials. When you see those ducts in large buildings, those have to be carefully placed in order to ensure comfort throughout the whole building by knowledge of thermodynamics and airflow. Now it may not seem like it, but seeing how these systems actually work can actually be pretty involved. Then mechatronics is like the combination of mechanical engineering, electronics, and some computer engineering. As a mechanical engineer, when it comes to robotics, you'd be able to build the robot structurally and make sure it can withstand a certain amount of force. But with mechatronics, you dive more into also the programming and circuiting of the robot. So with a mechatronics concentration, you'd basically have all the sub-disciplines necessary to build, circuit, and program a robot. And this has applications in embedded systems, sensing and controls, robotics, and more. Now the manufacturing concentration is a little more broad because you can learn things from the design of a part to the actual materials used for the part. Manufacturing might involve learning techniques that help you predict when a certain part will fail. This major will be helpful in teaching you that slight alterations in design or material of a part can have a drastic impact on the overall price, which becomes an important component in the design and manufacturing of parts related to profit margins and running a business. Now these are just some examples of concentrations, but there are many more sub-disciplines, and as a mechanical engineer you have a lot of flexibility. As a mechanical engineer you could work on cars, but to be more specific you could work on improving the engine to make it more efficient. You could work on the suspension of the car to ensure it can handle the forces that the car is subject to, like could it handle going over a speed bump too fast? Or you could do crash testing and look at the materials and shape of the car to see what it can withstand and how it would affect a person inside. Or you could maybe analyze how air flows over or through the car and optimize its aerodynamics to make it go faster from knowledge of your fluids classes. And this could even be applied to planes or drones. A mechanical engineer could also work with biomedical engineers on things like prosthetic body parts. They might need to help make sure the mechanism is strong enough to withstand the forces they'll have to put up with, or they might have to decide what's the best material to use. Mechanical engineers can also work on alternative forms of energy, like on wind farms, hydroelectric, solar, and more. They can work on satellites and use mechanics to analyze the vibrations during high acceleration, or they can use thermodynamics to analyze the temperature differences that the satellites go through as they orbit the Earth. They can work on robotics, weaponry, machines, and the list just goes on. As you can see, mechanical engineers really have no limits to what they can see in their career.